All right, welcome back. I stopped the video and restarted it because I was at 44 minutes, and so I didn't want the video to be that huge because when I uploaded, my upload speed's pretty slow, so it's easier to split it. So anyways, one thing that I said that I was like, ooh, for a second was, I think I said this was the extraction operator, but that's actually the insertion operator. The extraction one is the one that you use for CN, technically. So yeah, my bad for that. Anyways, so as I was saying, we're going to overload the insertion operator. And so we went ahead and put in the friend function here from part one, the end of that. So now we can go ahead and write the code in here to overload that. Technically, the either or the insertion or the extraction, they're binary operators. If you look at what that looks like, for example, we have a cout A, forget what A is right now, or we have something like cin A, right? And we probably have those in the other direction if we're actually coding something. But the point is that it's binary. The operator is here, and we have an operand here and an operand here, and the same for cout. So it's going to work in the same way that we have two parameters here. This is our left side, and then this one's our right side. And basically, that is how we are going to overload that successfully. So let's go ahead and give these some variable names. So we'll call that out, and we'll call this one just C for simplicity purposes. So now I can go ahead and do anything I want in this function, but because this is meant to write something to whatever it's calling it, whether it's cout or a file stream, we can go ahead and do something that looks nice. So why don't we just take what we have for the print and use that in here, since that's kind of what we're trying to replace. So we have our cout coordinate and then the x and the y, but we have to, because it's not an object, not a member function, we need to pass the object that we have to call that on. So we do that instead of cout, because right now we just hard-coded the cout. So it's not really going to work out if we're using like file streams from anything that's not the default std. We can just do the out. And one more thing that we need to do here, actually, because of how cout or cin works, we need to return that OS stream variable. And that's why it's passed like that. So if we go ahead and do that, and we don't forget the semicolon, then we're good to go. And so now, instead of having our print functions here, we can replace those by saying cout A. And so now we don't need this guy anymore. In fact, we'll leave it in for now so you can see everything printed out twice. And it should ideally be printed out the same. And then we have also the C here. So as you can see, everything got printed out twice because we called cout. So now we can go ahead and verify that it worked. And of course, this is much nicer than doing this, right? Well, that's debatable. But like I said, that was the goal, to be able to do something like this. Which of course, if we hadn't overloaded it, we would have gotten some nasty error. So for example, suppose we wanted to do the cin one, so the C read here. Then we might want to have to cout to C afterwards. But if I wanted to change the C read to say something like CNC, and I try to compile this, of course I get this big error. But actually, let's look at what the error truly says. No match for operator, and that is the extraction operator. So that's that error makes more sense now that we talk about operators, because we see that the operand starts at IS stream and coordinate, and there's no match because it's not built in. So that's great. Now that we understand what that is, we can overload the operator to do that. So let's go ahead and do that. So just like this guy, it's going to be very similar. However, instead of an OS stream, it's an IS stream. There we go. And so now we want to make it a friend function so they can access a private variable. So this guy's become very popular. It's got lots of friends, and so a friend like that. And you could leave this in here. Sure, why not? And then let's just go ahead and do whatever this guy was doing for the read. And then we also need to return that. And yes, I don't really think you should do this in the CN part, but that's just, we're just trying to make it match right now. So oh yeah, and we also need to say that these guys are from C. And I guess we're also missing a semicolon somewhere, or maybe that was just complaining regardless. We'll find out. No, it is still missing something. What am I missing? Oh no, on like line 33, so. There it is. Enter coordinates. Anybody have any suggestions? Let's see if I read your mind correctly. You said 87 and 41. So here we go. 8741, and we created an 8741 coordinate. So there we go. CN works just fine. And so there you have it. An example of operators that you can read in and write using user-defined data types that you can use C in and C out with after you've overloaded them successfully. So what else do we want to say about this? I suppose let's do one more operator. Or did we do already one? Yeah, we did a friend for the multiplication. So I believe that covers most of the basics. Let me see if I showed anything else in class. Oh, I guess I could show the string one that we did. So, I was saying how, things can get quite scary with operator overloading, with the string. So somebody said for the division, we're going to do the following. We have a division that takes the left and the right that are coordinates and is returning a string. Yes, you heard that right, a string. And so now, what that code is going to unfortunately look like is going to say return. The answer is, we have to use the string for this to work. And then, cast this to a double first. What am I doing? Oh my god, what just happened there? Static cast double L dot X plus R dot X, and then divide that by R dot Y, like that. And then wrap this all with a parentheses. And I guess another one. Where did that second one come from? Question mark. Oh, there's just two next to each other there. Unnecessarily. Okay. And then maybe cool. Not. Let's see if this compiles. Oh, I need the what is this? A string, probably string library. Or it was just the std C++11. Let me comment the C in and C out. And then let's go ahead and do the division. So we can do C out A divided by B. Oh, that was interesting. Oh, there's an end line, I think, at the end of that, so we don't need one. And as you can see, let me talk about what I did there. So again, it's taking coordinates and returning a string, and it returns a concatenated string between the following pieces. The answer is, and then it does a division, which it casts into a double, so that we force it so that it doesn't do integer division and lose the accuracy. So we cast one of the sides to double, so now we get a double out of that division, and then we make that into a string, and then we concatenate that along with the answer is, and there's also this cool knot. So now we get the answer is blah 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 blah. Maybe a space there would be nice. Cool knot. So yeah, you can do that with operator overloading, and you hopefully won't, but you can. With great power comes great responsibility kind of situation. Okay, now let me show you another operator that you can overload. Now I've shown you ones that you can overload only with friend functions. Let me show you one of them that you have to overload as a member of the class, and that's the assignment operator. But you know, this code got pretty big, so let's go ahead and move to a new code that is a little bit smaller. So let me quickly go over this code. So this little piece of code has some similar things, such as a class that has an x and a y, kind of like the coordinate. However, in this case, just to show you some of the issues that you can get, one of them is a pointer and the other one is a variable. And so we have a constructor that, again, by default makes a point with the coordinates 5 and 10, or otherwise you can pass in whatever you want since default parameters. And so what it does is it dynamically allocates the x pointer, and then it puts in this parameter, and then it puts that parameter there. And then because we're good programmers, we have a delete so that we can avoid memory leaks. And then we also have a little print function that will go ahead and print out this stuff. And so we have a main where we create a point. One of them is with custom values, the other one is default values. But then I wanted to show you how you would actually insert things there manually. And because they're public, just to avoid some hassle, we can access them by dereferencing that pointer, and this one you can access directly. So let's go ahead and run this code and see if it works. Great, it worked, right? We have 2 points with 2 different values. As expected, the first one has 2233 and the second one has 1155. Great. Okay. If I wanted to change anything in one of them, if it's the pointer that I want to change, I can use this syntax. If it's the regular variable that I want to change, static variable per se, I can use that, right? So, cool. Not static, by the way. Well, static in this is not dynamic. Cool. What if I do the following? If I do something like A equals A1, okay? If I do that, and then I print my data, whoa, scary stuff, right? Actually, that's probably because of the destructor. Let's let that be, because actually I'll tell you why that happened in a little bit. I didn't think that would actually happen there. Yes, so, okay. So if I do the following, A equals A1, I am basically copying, or at least I think I'm copying A1 into A, right? And then when I print them both out, I get both, as expected. As you saw though, this isn't the best code, right? There's some scary bug happening there probably. Okay, so let me, before I tell you about why this happened, let's look a little bit closer at what is happening here, like magnify basically. So what happens when you do this is based on the fact that when you have a class, one of the built-in operators that you could say are given to you that still work with classes. Some of them don't work, as you know. That's the whole reason we're overloading operators, right? Because you can't add to objects, and you can't see in or see out them, right? But you can do this without overloading anything, and this works just fine if you're dealing with just normal variables like this. The problem comes in when you're dealing with pointers, because I want you to notice something here. Suppose that I go in here, and after I set them to be the same, I go ahead and make a y 33. Okay? If I run this, I will get what I expect. I change A, so now it's 33. So first I set them equal, which would have given me this. But then I went ahead and changed it again so that they're different. And it, it matches. A is 33 and A1 is 55, as expected. So that's all good. However, let me do that with the pointer. Because it's the pointer, I have to use the dereference operator, right? So if I want to change that and maybe make it 99, notice what's going to happen. It's changing both of them. It's not, when I changed the 33, it was only changing that one. But with the pointer, it's changing both of them. The reason why is because I've made a shallow copy. When you do this, it copies over all of the member variables, and in this case, all that this is technically holding in the class is a pointer with the address to whatever these new integer is located in memory. If I wanted to find out where that is, I can simply say something like, give me the address of A1. Well, actually, I don't even need to do the address. I can simply cout A1.x, and that will actually tell me the address of that. What's wrong here? See, I was not declaring the scope. Using namespace std. And as you can see, this is just an address. And if I do that same address for both of them, you will see that it's the same because I copied over the pointer variable as I requested. It copied it. Actually, wait, what? Are those addresses the same? They don't look the same to me, right? Oh, it probably just... Oh, no, they are. I was just looking at this A, but that A is not related. It's because it's looking at this guy. That scared me for a second there. Made me question life. There we go. Okay, great. So now I'm not questioning life. So now, yeah. So basically, when it does the copying over here, it's copying this value into another variable, and it's copying this address into another variable. So there's two variables, but they would have the same address. So you have two pointers pointing to the same address, which is this new integer's address. That, of course, is probably not what we want to do when we make a copy, right? We're expecting it to be a clean copy, but that would require you to have a new integer that has that location. And guess what? You did get a new integer when you did this. And you then created a memory leak, because when you created it, the next thing that happened was it overwrote it. So there is a memory leak. And furthermore, the reason why it's crashing when you call delete is because when when does the destructor get called? When the object goes out of scope. So when the program is ending here and the object is going out of scope, it calls a delete. Now remember, they're both pointing to the same location. So the first object that goes out of scope, which, I mean, they both go at the same time per se, but the first one that technically gets the destructor run calls delete on that address. So it deallocates it. The second one also tries to deallocate the same address. And depending on your operating system, such as in this case, Ubuntu 14 or 16, I think it's 16. Maybe it's even 18, I don't remember. Then it's going to probably crash because you're trying to deallocate something you've already deallocated. Some hardwares, I think you get lucky that it doesn't crash. But I'm actually glad that it crashed here, because it shows that problem that you may face doing something like this. And you will pull your hair out not understanding what is happening if you don't truly know, the inner workings of this. So that's the problem. How do we solve this problem? Well, we can create what's known as a member-wise copy and a deep copy. So deep copy, you want over, when you have two arrays, you basically allocate another array, and then you copy every member of the array, so every index, manually, right? That's kind of the same logic that we're going to do. So let's go ahead first, before we do anything with operator overloading, is just go ahead and create a function that will take care of this for us, because that we know how to do. So in this function that's going to be called a copy, because it's class A, we are going to copy the values of y like this, and that's the easy technically, and then we're going to copy the pointers too. For the pointers, you know, we can't just do this because this is technically, this right here is technically what the default assignment operator copy is doing. It's copying the pointer addresses, but we don't want that. What we actually want to do is copy the contents over. So we use that with the dereference operator, like such. So now it's copying the contents and not the address. Now we don't need to do a new call here because the constructor takes care of it. If for some reason it didn't, then yes, you would have to do a new call here on in the form of doing something like this. In fact, I could do that actually, but now I've created a memory leak. You know, that'll work just fine, but technically it's a memory leak right here. You know, I'll put that in memory leak because you already made a new integer in the constructor. Exclamation point. Because memory leaks are bad, right? Okay. So now instead of doing this because it's bad, you know, then we can go ahead and use our a copy function and pass in both a and a1, and we're copying from right to left, so yeah, that'll do the same thing. Oh, and you know, make sure that syntax is correct there. We do that, and now we've solved the problem. We're not getting 99.99, right? That is doing MRBus copy. And furthermore, this shouldn't crash anymore when you do that. And it did. Dang it. Why did we crash? Did we get rid of this thing here? Well, we don't need this line of code anymore, but delete X. I'm not sure why we crashed actually. We make them to, we use copy. Copy is actually copying just the contents. Out of sheer curiosity, if I do this, do I crash? Oh, I seg fault. That's nice. Oh, well, probably should be doing that in the first place, passing by reference, shouldn't I? Although it shouldn't quite matter because it's a pointer. Oh, okay, there we go, problem solved. Passing by reference. But yeah, anyways, basically the reason why was because we weren't updating that, I suppose, but now we are. So anyways, yeah, so this will solve the problem by doing a member-wise copy, right? Okay, of course this is a function, but we want to be able to use this syntax. So what do? We overload the operator. And so you can only do that as a member function. You can't use friends for this one. And so how you do that is as follows. There's a lot of cons in here to protect yourself, if anything. Remember, that kind of makes it like read-only per se. But yeah, so what you do is you pass in your return type is going to be an object of the same type, and then you pass in the right side. So basically that's the A1 and this is the A. And you need to do this one check, but I'm not going to do it yet because I want to show you the bad things that can happen. But for now, we'll go ahead and do something like y gets ry, and I can use y because the left side I am passing here as a member, so that's okay. And then I can go ahead and throw in the right x like that. Okay. And so now, oh, one more thing I definitely need to do is I need to return the result by returning this like that. Okay, so now I can go ahead and do the following. And all right, there we go. We're good. Everything works as all things should be, right? So like this changes that, but it's not affecting this guy. And we are using the delete, so there's no scary bugs inside happening. Great. All is great in the world, right? And not exactly. Suppose that I was evil and I assigned myself a few times. You know, it works fine now, but technically this is really bad what I'm doing here, because when I assign myself, suppose that I was being a good programmer and I wanted to be safe about what I'm doing here to avoid memory leaks. And so in this assignment, you know, what would I do to avoid memory leaks is I would probably delete X before I do anything to it, right? Because if I delete X beforehand, then I will not have any issues potentially with memory leaks per se, you know, or whatever, you know, and then you can make another one or something, you know. Oh, X, what am I doing here? X gets new int or something, you know. Suppose that I was trying to do something like that to avoid memory leaks, you know. But the risk with doing all this stuff is that when I'm assigning myself, I can run into some bad problems. And so to solve all of this, I can do something that checks whether I am trying to assign myself by saying, is the same address of the right the same as the left? And then I can just simply return at that point and not do anything scary. And by doing that, I will avoid any sort of self-assignment problems. Like such. Otherwise, you can and you will run into some bad bugs later on. So that's just one thing that I wanted to point out. So yeah, that's one operator that you can overload, and you have to do it as a member. So as the last things that I want to talk about are some of the formalities of operator overloading. And let's start by talking about the restrictions behind what you can and cannot do with operator overloading. So this is from your book. So let's kind of run through these and talk about them. So first of all, you cannot change the precedence of an operator. What that means is that when you get an operator, such as addition, and you get an operator like multiplication, so you have something in the form of A plus B times C, this happens first before this, right? Because order of precedence. So, you know, if you had something like an exponent or a parentheses, that's way up there in the order of operations, right? So because of that, when you're overloading operators, you cannot just magically make it so that the addition will for sure happen before the multiplication. You cannot mess with that. That is set, and the reason why is because when it checks whether the syntax is correct, and it does all the compiling, parsing, and type checking and all of that, there's a lot of checks that need to be done, and those checks are dependent upon whether the syntax is correct or not, and some of that is checking these operator precedences. So you cannot go in and change that. You have to stick with what's available. So if as part of your operator overloading you assume that this addition will happen for the multiplication, well, then this won't work. Kind of building up to that, the associativity cannot be changed. So, for example, in math, if we have a plus b plus c, so not multiplication now, but just addition, you know, the technically, like, you could say that this could happen before the a plus b, right? Well, no, we at least in C++, it has been kind of defaulted that you read from left to right. So you will always get the a plus b first before you get to c. And so that associativity can't be changed, as it would potentially, you could argue that in math, right? So you have to follow those rules. Furthermore, because you have something like a plus b, which is a binary operator, and you don't want someone to do something like a plus and then have some magical number default to be here, or vice versa, because that would create problems with unary operators. Because of that kind of thing, you cannot have default parameters which will fill in the blank per se. So you have to you have to have regular parameters that are not default, so that way there's no problems with the parsing again. Furthermore, you can't change the number of parameters that a operator takes. You cannot make something that's unary operator and turn it into a binary, or like some sort of triple operator that has like one operand on this side and two of them on this side, and it's like there's some magical operator that adds like a plus b and then multiplies that times d or something. I don't know. You can't do that. Furthermore, C++ has a certain amount of operators which you can very easily look up, and you cannot make new ones. You can only overload existing ones. And even within that list of operators, there are some that you cannot overload, and those are found here. So this is the member. So the single dot here, that's an operator. That's the member dot access operator. So that's when you do something like a dot foo, and foo is a member of the class. We've been using that all day today here, as you can see, right there. So you cannot overload that. This is the pointer to member, or member to pointer operator, which I promise you I will find out later on and talk about it in class, but not right now. Then we also have the scope resolution operator. That's the one where you can use also for namespace and things like that. So you do something like that. You cannot overload that. Furthermore, you cannot overload the ternary operator or the size-off operator. The size-off is like the one you were using when you were playing with malloc. Let's talk about the ternary operator, because sometimes people aren't too familiar with that one. So if I have something in the case of like if a is greater than b, and then I say something like c, maybe a gets 1, otherwise, or actually, how about c gets 1, or c gets a, otherwise c gets b. So that way, like, basically, c is going to have the biggest value, or at least the tithe for the biggest value. You can rewrite this statement into, and of course you have an int c up here. You can rewrite this into a single line of code in actually two ways. Let's do it into 2 lines and then to 1 line. So you can rewrite this into saying something like a greater than b, question mark, c equals a, colon, c equals b. And it can even be simplified further, and then of course you need your C declaration. It can also be simplified further into doing something like int c equals a greater than b, question mark, a, colon, b, like that. Yeah, okay. So how do I go from this guy all the way to this guy? Well, the ternary operator is relatively simple to understand once you kind of remember which is which. So the first part of it is the conditional that you put in the if statement. The second part of it, so after the question mark but before the colon, is the true statement. So that's what happens if this condition evaluates to true, it executes whatever is found here. And it could be a million lines of code or just a single command statement like this. They're all basically there until it hits the colon. And then on the other side of the colon is sort of like the else clause. This will execute if the conditional in the front gets evaluated to false. Another little neat feature that the ternary operator has is that rather than this being statements, they can be used to assign, such as here, where I'm assigning either A or B directly into C in a single line of code. So I'm saying assign to C the either A or B, which is depending on this condition. If A is greater than B, assign A to C. Otherwise, assign B to C. So all these three are interchangeable. If you ever want to kind of make this a little bit easier to read, you could kind of separate it almost like if it was a normal if statement. So maybe like this. And I think that now it might look more familiar to you, because this and this look very close now. You can think of this like the if part with the question mark, true to the if, else, and then false to the if. And it's a little bit harder to split this one, but you could, I guess, do something like this maybe. I don't know. That one's just kind of weird. But yeah, that's kind of the ternary operator. So the long story of that, the short story of that, whatever, is the fact that you cannot overload that one. I'm not actually sure why, personally, but you cannot. Finally, the last two rules talk about what I've already kind of mentioned, in the sense that you cannot redefine how operators work within built-in data types. So if I have int A and int B, and I'm doing A plus B, I cannot magically turn that from an addition to a subtraction or some weird operation. Those are built in, and it's kind of like, it's a good rule in the sense that you can't have someone ninja their way into changing how addition works between two integers. Well, you can change an addition between an integer and a user-defined data type, which is what the 8th rule says. You cannot just do it strictly for built-in data types. So you can't change how integer division works, but you can change how integer division works between an integer and a coordinate, or a coordinate and an integer. That's basically what that is. So in addition to that, I'm looking through the book here. You will read chapter 13. There's a couple of other operators that I want to briefly mention on how to overload them. And yes, this is actually quite useful. So this little statement from page 921. The function that overloads any operator of parentheses, the array index, arrow, or assignment must be declared as a member of the class. So this is the one that I was talking about, where if you're doing the assignment operator, or any of these other ones are the ones that you have to do as members of the class. So I showed you this one. These other ones you can look up on your own on the book. There's a section on binary operators, which we've mostly talked about all of that. Here's a good sort of generic syntax on that, which is exactly what we've done. Return type, class name, operator. Then yes, you can put some cons to avoid changes. And then your algorithm, and then your return value. My puppy is licking me. It's kind of distracting. And then there's talk about more binary. There's stream insertion and extraction. And then the assignment operator that we talked about is in there. Okay, overloading unary operators. So let's talk a little bit about overloading the pre and post increment. And the reason why I want to talk about that is because it's a little trick that you just, oh, my hand is dirty from saliva. Okay, dry that. Okay, there we go. So let me show you this one real fast. So they have a rectangle type in the book, and you're overloading how the pre and post increment work for that. So in this case, they are going to go ahead and overload the pre-increment operator. So that's the one that, you know, if there was a rectangle type object like such, and it was called A, and you did something like A++, or my bad, sorry, plus A, what would you do if you're overloading that? And that one's relatively straightforward. You do it as follows. You put the return type, and then you put the operator, and then you do plus plus. And so in this case, it's quite easy. You simply increment using pre-increment both of these, and then you return that. So you return the incremented value. Boom, done, easy. no problem. However, the trick comes in when you're trying to increment in post increment. And the reason why is because if we remember with post increment, you actually get the value. So if I have an operation, something like a C out plus A, and in that case with pre-increment, and suppose, okay, for now let's say A is an integer and A has 5. If I do C out A plus A, I'm going to get 6 printed out, and the value of A after this operation is also going to be 6. However, if I'm doing post increment like such, in this case I'm actually going to see that 5 gets printed out, but if I was to then again print out A, I'm going to see that 6 is actually what's in A. So you get the old value of A printed, and then the increment happens, right? That's the cool thing about post increment. So when you're overloading that, you kind of want to keep that property as part of the overloading. And so the little trick you got to do to this is that you make a copy, a pointer copy per se, of the old one. And I'm saying it's dereferencing it. So you're making a copy of the old value of whatever rectangle type is. Then you do your increments as you did before, but instead of returning what you just incremented, so the new incremented value, you return the old one. So doing this little trick, you can kind of maintain that sort of same concept of how A++ would work, in the sense that I'm going to increment the values in however way I want to do, but I'm still going to get the old value back first. And the other little hack that you have to do this is it needs to pass a parameter here. It needs to pass an integer. And the compiler technically compiled this by the statement my rectangle, if that's the name of the class or whatever, the object that you're calling it on, like that. And it actually passes a 0 to it. And that's how the compiler actually internally works, to make sure that it understands that this is actually post increment and this is pre-increment. So this is some just nasty hack that you just accept as part of life kind of thing. So yeah, that's the only sort of trick to pre and post increment that I wanted to mention. It's not something that I tend to put on the test, but it is definitely something you should know, and it's actually quite useful if you want to overload that operator. This is another sort of basic syntax of the same thing that I just said, for your reference, like that. And it gets compiled. Oh, by the way, how you include this in the definition of the class is like this. This is how you would put it in. You put, of course, with the integer. But technically, like I said, when the compiler sees a function call like this, what is technically actually being written in the compiler is going to be, whatever this object name is, dot operator plus plus, and then a 0 there. And that's how I know the difference between pre and post, because this one has no parameter and this one has a single parameter. It's an integer which gets a 0 always. And so that's pretty much all that there is. There is a little mention at the end of the book about the copy constructor and the destructor, and so I believe this is known as the 3 C's or the 3 rules. Let me read this real fast to see if the name is here. Well, this is good to point out. The only built-in operations on classes are assignment and member selection, which is a little dot. And as you saw, even with assignment, there's limitations, which is why we have to overload it. Because member-wise copy does not work well for classes with pointer member variables. And other problems that may arise with classes with pointer member variables relate to deallocating dynamic memory when an object goes out of scope, as we saw, and passing a class object as a parameter by value. So the rule I think it's called rule of three or something, is basically that, that it says if you change one of these or if you add one of these, you should do the other two to avoid problems. And those are that if you're explicitly overloading the assignment operator, you more than likely also want to include a copy constructor and a destructor. And that's just the basic rule. If you're also including a destructor, more than likely you want to include a copy constructor and overload the assignment operator. If you're including a copy constructor, more than likely you want to include a destructor and the overloading the assignment operator. What I'm saying is, if you're messing with one of the three of these, you will definitely want to change all three, because otherwise you're going to run into some scary bugs. And so I strongly suggest that you read the chapter and look at that, because that is definitely something that is going to come into play. So I think that wraps up the discussion on this, on operator overloading. Maybe very fast, I'm going to show you the copy constructor Geeks for Geeks sample on that, on how to do that maybe. Yeah, why not? So, okay. So here we have the copy constructor. And so what is the copy constructor? Well, as you can see here, it's a member function which initializes an object using another object of the same class. And so basically, when you create an object, you might end up doing something like this. Make an object that is basically the same as the previous one. And see, there's assignment going on here, but actually what's going to get called is going to be the copy constructor. And your copy constructor kind of looks like a normal constructor, but the only difference is that the parameter that the constructor has, which of course the default constructor is like the one that has no parameters, right? Then you could have something like this, which has custom parameters. This is just another one, but in this case, it's going to have a parameter of the same type that you're creating, such as this with point. And so what you do is you put the little cons here to avoid any scary errors. And basically, it's kind of like the member-wise copy. Whatever you do in your member-wise copy assignment overloading, you're going to do here as well. And that's basically to solve any problems with pointers more than anything. And so by doing that, you can basically avoid problems. And you can go ahead and read this and talk about it. But basically, again, you will be doing in the copy constructor the same thing that you would be doing in an assignment operator, in the sense that the copy by default, you know, with the assignment, you know, you have problems with the pointer variables, and so any sort of those issues you will want to fix here as well. So if you have any questions on copy constructors, you can bring it up in class. But for now, I think I will end the video, and I may make a part 3 to the video to talk about the homework, but it's kind of specific to the class. I'll keep it out of this video. But I thank you for watching, and I hope that you learned something today. Or if you're watching this before a test, best of luck with your test. Thank you, and I hope you have a wonderful day.